focusing more on the blast design and importation of the drill hole deviation information. Before we get there, I just wanted to briefly take a step back to where we kind of finished off last week. On the screen in front of you, we see a drone point cloud. And what we notice is that on a lot of the face, we're missing vital information. And while we can go to surfacing and quickly create a viewpoint from this, we're creating a best guess of what that profile is. Whereas if we were to use a drone in conjunction with the Quarryman, for example, we'd be able to overlay the two different point clouds together to get a complete picture of what that face looks like. So here we have some missing information, but as I mentioned, when we slowly lower the trim, we're able to fill that out, and so we're still able to use some information in order to design our blast moving forward. Now, the other thing I just wanted to briefly touch on is, let me just load that point cloud here. It is kind of what I also touched on last week, the ability to add markups to our point cloud from our drone before continuing onwards. And what I'm going to do here actually is I'm just going to create this surface first, maybe not so much with a low trim again, but we're just going to quickly execute this. And what I want to show is that ability to use the colorization of the point cloud to highlight areas that we could use for our blast. So here we've created the pattern, and what we've noticed on here, and this is not a great example, just because these markers aren't necessarily for the perimeter of our blast. But I mean, say it was, just for our purposes here, we could insert a collar right where we see these marks on the field. So if we're doing marks on the field before continuing on, then we're able to use that data in Blast Commander. So with those two selected there, we could see them from the bottom, one on our right, one on our left. And so when we're able to, once we're ready to go over into Blast Commander, we're just going to use this export to Blast Commander icon to decide what we're bringing over. In this case, our surface, as well as the two collar points that I highlighted. And so this will just run right over into the Blast Commander portion of the software. Just to open it up from fresh, if we were to open up our BlastOps software, give it a second here. Rather than going into our Cloud Commander here on our left, creating our surface and then bringing it in Blast Commander, if we already have our surfacing, whether it's a tin, grid, or DXF file, then we could go right into Blast Commander to design our pattern. But coming back into here, yeah, we have our two collars, and what we can do from that is really use that in reference to our pattern going forward. So this is the layout for Blast Commander that you see here. Very similar format to Cloud Commander, starting off with our project tab at the top, where we could save our project, change it if we want to switch to something else. Very similar to project or to Cloud Commander. We have our project settings, so we could enter in any information, change our units if need be, or import any ground control points, which those aren't actually relative. So I'm just going to delete those out. Next, we do have an Optimuck import. So for those people using that system, if there's some information you do want to bring over, we have a number of different steps to go through, kind of very similar to the FSC wizard, which apparently is at the top there, in order to bring that information in. Under our surfacing tab will be 4 icons. We have our volume, which I'll actually touch on very quickly. But before that, we'll go into our surfaces. So our surface that was created in Cloud Commander appears here on the right, highlighted in green because it's on. If we click it, it'll turn off. And if we use this red button on the right here, it'll actually delete it. So any kind of surface, again, tin, grid, DXF, we're able to bring those in. So I have some tins pre-made that we'll take a look at now. While I did mention the ability to calculate a volume, I'll just quickly bring in this stockpile here that some of you may have remembered from last week. And in order to compute the volume, it's a very simple, we're just drawing our toe around the crest line, just clicking as we go. And when we're finished, we either hit enter or we right click in order to finish our selection. And we'll just give this a second to calculate the volume. So we get our volume, and we can see where our base is with the darker blue points, and then our topography surface, which is our stockpile here. Now you're going to see this line feature come up quite a bit in the next little bit. And by right-clicking it, we're able to start editing the line, and this brings back our vertice nodes. And so the darker red ones are vertices. So if we move that, it's just a matter of moving it. If we do use one of the center points, that itself will become a vertex and will create 2 more center points. And so it's very easy to manipulate any of the line work, whether it's for our volume calculation here or for our blast design later on. So let's just go ahead and delete that out now, and we'll take out that volume as well. The next one is a pad maker, and perhaps before I do that, I'll actually bring in one of the surfaces we'll design a pattern on. The pad maker works in a sense that we could pick a center, we could input some coordinates here. I just clicked on our known floor here, and we could specify an azimuth, an angle, a length and a width. So if I made it 500 by 500, for example, click create pad, we have this pad. So we could use this pad going forward as our bottom surface for our hole depths, for example. We could, if we were looking to design a ramp, maybe we would add an inclination there. Not the right way, but we could then use, again, this pad in order to design the hole lengths for our blast relative to this surface. So this works in a number of different fashions. Rather than creating a pad yourself, if you do have a tin or some information that we're using as our design to base, whether it's a file created through Carlson's Office software or elsewhere, then we can bring that and use that as a reference. So here, this might look familiar from last week. We had created this surface from a drone point cloud. And what we're going to do is create our pattern. Before we can actually go into our blast pattern layout, we'll get this error saying no crest line. And so we have this this mid step called blast lines to give us some more information. We're required to provide a crest line as well as a toe line. We also have an optional blast boundary line. Now, this was added in as a mid step towards something bigger. What we would actually have in here as well as the option for a muck line. So if there is muck material in front of our face, we would draw our crest line, our toe line, and then our muck line. and then we're able to essentially remove that muck from our face and from our burning calculations going forward. So this does have a bigger idea in mind. But let's get on with our pattern design. So our crest line, as you'll notice, uses the same line feature as does pretty much any other line that we have in the software. So we're creating a left click, we're creating vertices, and then either a right or an enter to finish off. Now, the one thing about this is that it actually drapes right to the surface. So while it looks straight from where I drew it, it actually is draping right onto the surface here. And sometimes we might want to correct that if we edit this. Maybe I'll just click this, create another vertex, and we'll take that little dip into the crest itself going forward. Essentially what our crest line is, big picture wise, is our reference for our first line. If this is straight, if there is a kink in it like there is here, that can all be taken into consider with this line. We could even expand this line if we wanted to also blast out this little overhang. We could drag that line over even further. There's a couple of different ways where we could design this blast. And so I'm going to take you through the different steps in this particular data set here. So let's just finish off here, stop editing line. Let's go bring in our toe line. So we'll just quickly click along. How specific is up to you. And then our last option here, which is optional, is our blast boundary line. And maybe I'll actually take a step forward just to kind of show you what that blast boundary line would do. Just quickly go in here. I will go through all this in very quickly. I just want to create a quick pattern to show you the difference between the two, and maybe we don't want a 40. Why are all these so big? Okay. Maybe I should have used bigger spacing for my holes. So without the blast boundary line, it essentially fills along the crest line that we've created back based off of the number of rows and the spacing along with our color spacing here. What our blast boundary line does is allow us to use non-rectangular shapes in order to define our boundary area. So if we wanted to, I'm going to get a little crazy here, not a realistic blast by any means, but if we create this blast boundary line, I'm going to increase that spacing just so that we're not creating so many holes. But if we now recreate that pattern, it limits the area to which these holes are allowed to be created. Now we saw a lot of red notifications there, just saying that the hole couldn't be created because it's outside of this area. So that's what the blast boundary line does. So maybe let's delete that out and actually do it properly. We got holes. All right, so we're just gonna go. No, I don't know. There we go. We're just gonna use almost this whole thing for our pattern. Now, what you may have noticed is that I've included this this ledge here before my crest line here. And the reason for that is rather than drape across the entire crest, what we want is a more, I guess, row-based pattern where the rows are straighter, in which case I'm just draping this right across over on top of our bench. And how I'm going to do manipulate that is with our first burden and our first column offset. Essentially, these will move our first hole and subsequently the rest of our pattern relative to our left starting marker. So our first burden, in this case is 10, would move 10 feet back. And then our first column offset, say it was also 10, would move 10 to the right. So that it's an easy way to reposition our blast pattern if we are looking to do so. So we'll leave it as a 20 by 20 pattern, sure, 10 rows. And so what, in order to get holes behind this, I'm just actually going to create a negative burden, and maybe we'll put at -10, and we'll leave that first column offset at 0. Actually, I realized I just jumped into pattern geometry without explaining the other two, so let me just take a quick step back there. Collar elevation. So if we have our top bench surface, we're going to want to use our grid elevation. That way, each of the collars that's created from the software will meet right with the surface, so that we have a correct Z coordinate for that collar. On the other hand, if we went out with a corpsman, we just set up one down on the lower bench here to survey our profile. We don't have this top bench, then we would use our high wall elevation. And what that would do is uses the elevation of our crest line to dictate what the elevation of our collars are. Ideally, if you are using the corpsman, especially for blast design, if you set up down on the bottom, take a couple of extra minutes, go on top just to do a quick get some quick information. It doesn't have to be a full scan. You could even use the auto fix just to manually move it and gather some data up there, just to get that, and that way we can constantly use our grid elevation and we're not switching between those. Our toe elevation is for the bottom of our holes. Now we can control this by a number of different parameters. Elevation, in which case I put 350 here, relative to what I'm considering the floor. We can see our Z right here in the bottom right. So that's how I kind of just determined that. We could also base it off of depth or length, or as I mentioned before, if we created a pad to use as a reference, or brought in another tin or grid file to use as a reference, then we could use surface to specify which surface the hole should go to. And that brings us to geometry. We've covered our rows and columns fairly well. I guess the one thing I didn't mention, I'm gonna hide that too, was the ability to choose our columns either based off of the number of columns or the spacing of the columns. So here I have it spaced out at 20 feet, in which case we would have 19 columns. I could switch that the other way and say maybe I want 10 columns, in which case I would have 40, almost 42 feet between each hole. Not ideal. But yeah. The next is our pattern characteristics. So if we went to just execute this pattern right now, let's see what we'll get. We have those holes on the other side of our grid line, our crest line, because of our negative burden. And right now we just have a nice square pattern, and maybe I'll look at this orthographically instead of from perspective. But if we were looking to do a square pattern, we could just change it to staggered. We execute that pattern, and it'll change that for us. We also have this dynamic layout. And so, wrong area. Dynamic layout. So what this will do is follow our crest line. So because it's draped on the surface, we might get some bumps or some wiggles back and forth, or in this case, an indentation right here. And so if we turn on our dynamic layout, we execute that pattern, we're going to see that a couple of our holes because it bulges out here, a couple of holes didn't make it within that blast boundary line, and we can see that our B15 hole here and the rest of the holes are kind of skewed back because of that kink in our face, which is also why we have our fade dynamic offset. So if we had, so say we don't want this kink to carry on through our pattern, we want our, say our 7th row to be our first straight row. That will slowly fade out that dynamic until we get a straight row again. And I mean, we could just to give you an idea, maybe I'll just draw this crest line again, a little crazy here. Probably won't have all those patterns. And I mean, if we change that to our first straight row as our second one, we could see the dramatic shift between our first and second row there. So just some of the functionality to kind of see the different ways that these features can be used. Let's just, we'll delete that line, and we'll just draw that right across again. Now, we need to know how this is still relative to the face. Now, we could click one of these holes. Maybe we want to turn on our distance lines. Might be a little bit far. Let's check out our burden options. Yeah, that makes sense. What was our 20? Sure. Let's, all right, clicking everywhere. We'll just change our desired burden to kind of meet what our pattern is to see what our holes look like. So we have this colorization here, which a lot of this hole is actually in green. Because we're within our desired burden plus our tolerance. And right now, if you look straight on at this, you'll notice that this isn't a straight face. We can turn on our straight measurement, which might actually change it to look somewhere else. No, it's actually looking perpendicular to the wall, which then we could change, I mean, on a vertical hole, perpendicular to hole or parallel to ground are the same thing. Those would be more for your inclined holes, seeing the different burden measurements there. Turning off our straight measurement would give us our critical path of our hole. So we would see the weakest burden for that desired hole. And rather than looking at individually, we have our burden vision that we could include here. Maybe I'm just going to take a quick subsample of the surface rather than the full thing. But creating our almost like our blast boundary line. This is our face profile area essentially, and maybe we'll increase the spacing in that. But by creating this surface, we'll see the colorization of how all the holes are affecting our face. And I should explain that the lower these values are, the more information there is in this surface, and the longer it might take to create. So here we're seeing, I guess if we want to go through the explanations of the colors, red, you're too close, green, you're within your desired burden and tolerance, blue, you're too far. So we're getting a little bit of everything in here. And so we can try and fix this through the pattern. Maybe we don't want our dynamic layout. Actually, I think I just drew a straight line, so I don't think that's necessarily relative at this point. We could go in, edit this again. I mean, I'm not going to spend too much time trying to finesse one specific pattern, but I want to at least provide some information so that you have an idea what these features do going forward. I guess explaining some of the other features in our blast pattern layout. Under pattern options, we have the ability to indicate our hole diameter. Now, if that hole diameter is too small, we also have a scaling factor to make it easier to see. And maybe I should have done that on some of these holes to make those colors easier to see. A little bit thicker. Label size, that as you could probably guess, that is for your label size. Burden options, we've gone through most of that. Actually, turning on one of these holes again. Right now, it's measuring every 10 feet, which is a little much. So we could change that to measure every 2 feet. This will change it for all the holes, so this might require some patience while it updates. But even for the amount of holes we have here, we could see that changes relatively quickly. Burden vision, I guess Voronov options. So that's what these hexagons. I don't know why that word escaped me there for a second, but that's what these hexagons represent, is the Voronov volume relative to that hole. So if we go into one of these holes, go down on the left here, we can see the Voronov volume associated with that hole. And so that'll change based off of the spacing, things like that. I guess actually to break down the left-hand viewer here, we have our hole tools, which I also docked my Scene Explorer in there. You'll notice that on the Scene Explorer, there's that arrow, so we could undock it or redock it so that we have as much of the viewer as possible. Going down here, we can see our coordinates associated with our azimuth, length, to elevation, all of which could be changed. If we want to expand this down, maybe we want this to actually go to 370. And I guess I should have gone the other way. Was not thinking there. There we go. Now it sticks out. We could also just change the drill angle, just either entering it in or using our scroll, or even the buttons on the right to increase those. The other thing is just the movement of the holes. If we're looking to move a specific hole, maybe because of the pattern, it's in a corner, it's not exactly where we want it to be, like this A4 example, really close where we've seen red the whole way down. Maybe we want to move this. And so by highlighting this hole, we could use our arrow keys to do that. So our back key would move it away from the face, or down arrow, I should say, whereas our up arrow would move it towards, and then our left and right arrows would move them in that respective distance as well, which is also all controlled through this movement. So right now it's only moving 1/4 of a foot each time, which is a little small, so we could change those to move more drastically each time. You also have the ability, again, maybe this A3 is not exactly where we wanted to place it. It's not in a bad spot, but maybe we still need another row over here, in which case, I mean, I could change the parameters I put in. Otherwise, I could go into our drill commands, add hole, and then just, I think I might have actually clicked outside of the blast boundary area, but here we've inserted 2 holes, and then if we want to make sure it fits with the rest of the naming convention, we could always go into our information and change that label there. That's almost it for for blast design. I guess the one thing I haven't actually done is actually use this crest as our back row. So if we're looking to design, maybe I'll delete all the holes. If we're looking to design from the back forward, we could very easily use our crest line as our back row. Indicate that's our back row here, just under our pattern characteristics, and then it would compile forward. So it's all a matter of how you're designing your blast, what approach you want to take, and actually it worked out pretty well considering. And from this, there's a few things we could do. Under blast pattern layout, we could create our drillers report. So if we create our drillers report here, we could specify if we want, if we're laying out our pattern in the field, not necessarily using a GPS, but using some defined markers in the field, we could specify what those markers are, I should say, sorry, so that we could see what the distance and offset are from those markers for each of these holes. But I'm just going to leave these as a face extents definition, and I'm just going to put this right on my desktop there. And so what we could see from it is a breakdown for each of our holes. We have our B1 here, total length of 152 feet, no sub drill, azimuth. Well, there is an azimuth there. It is the vertical hole, so a little redundant. But then here's our, again, distance from marker and offset if we are laying it out based off of the marker in the field. Otherwise, there's our X, Y, Z that we could push to our GPS. We're able to export a CSV as opposed to a PDF. So just going through drill commands, output CSV, we're able to create an XYZ file essentially to bring into a GPS and then go lay out our pattern. And then another way we could do it is, again, if we have Carlson command, we're able to push that through the cloud to the onboard computer of our smart drill to get all that information right there. And that, sorry, I didn't realize how long that would have taken. Just explaining all those. I mean, I had a couple of other data sets, but they're all very similar, whether they have hangout like this or maybe a kick out to the right, so it's not necessarily a flat face there. But I guess the main takeaways to realize is that the crest line is essentially what your pattern's in reference to. Your blast boundary line allows you to limit that area, and then based off the pattern characteristics here, we could either do a staggered straight pattern or a dynamic layout pattern. Actually, I didn't get a lot into hole dips. So right now we have our blast face azimuth checked on, and so it's essentially using, if we were using our crest line as our actual crest line, it would be the inverse of these green arrows. But because we're using that as our back row right now, that's the direction that our whole azimuth would be in. Right now there's a vertical angle, but we could easily add, say, a 10-degree increment to that. Now, let that re-execute the pattern. There we go. And we also have the ability to fade that out. So we have, very similar to the fade dynamic layout, we have a feathering of the dip. So we could specify our desired end angle and by which row. And depending on how that all calculates out, we have a snap increment in case drillers can't shift by a quarter of a degree or a half of the degree. And so by specifying what our snap increments is, we'll always ensure that that it is something that the driller can do. And so here, yeah, 0 degrees on our 5th row. And if we re-execute that pattern, we'll see that slowly fade out. And it's because we're using it as a back row that it actually fades out the other way. What else is there? Oh, Boretrack import. Yes. Last but not least, Boretrack import. So say we've exported this to our driller now. We sent that onwards, whether it's the onboard computer, our GPS, the pattern has been laid out, it has been drilled. We now want to bring in some Boretrack data. And so this is a matter of, actually, let's just reset all these holes. I'm just going to reset this crest line quickly again. Just go across here. Just creating one row. Maybe we won't do the dynamic layout. And we'll move that back. And we'll bring these back to vertical holes actually, and we won't tether it. So whether it's with the Corpsman or whether it's collars that's been surveyed in, again with the GPS, feedback from our onboard computer, or observed with the Corpsman, we would have our collars laid out after it's been drilled. And we're looking to attach some Boretrack data to that now. And so that's all done, again, under blast pattern layout. Give this one, there we go. Under import, we're able to bring in our survey data. So again, our hole collars, to which we would then attach our Boretrack data to. So with our Boretrack here, we have the ability to bring in the legacy rotted Boretrack data files, the new Carlson Boretrack DRL files, as well as the cable Boretrack files, either through a link or through the file. Because I don't have a cable Boretrack with me, I'm just going to import it from file. It's just going to select this .dat Boretrack file, which we'll click next. Now, here we're just matching the holes in the scene, what we've created or what's been observed with the Corpsman, with what's been taken or observed with the Boretrack. So we can easily manually combine these two together. Otherwise, we have a match by row and column name in order to attach the Boretrack data to their equivalent holes. And because the cable Boretrack does use a magnetic compass, we also have to account for magnetic declination. This isn't relative to the rotted Boretrack, but with the cable Boretrack, we have this Boretrack alignment vector. Essentially, in the field, we've gone out and we've seen that we've observed a known baseline here at 205.63. Essentially, what we want to do in the software is by clicking this Boretrack alignment vector, ideally we're in orthographic here, we would say replicate what we did in the field. So maybe we were on hole 1 and we cited hole 7. Once we're in that desired viewer space here, we'll hit enter to lock that in and bring in our line feature again. We'll see that red dot following my cursor around. And we'll just select A1, then A7, and we're not going to see a consistent grid because these two data sets aren't combined, but get you a general idea. So this will rotate either negative 154 degrees, or I guess that'd be counterclockwise or clockwise, the other 210. But regardless, it'll then make sure that it's referenced to our Quarryman or drone data. So click finish. Really click finish that. Ah, there we are. Get an exit out. Maybe here, let's show our Boretrack instead. So yeah, a lot shorter than our design holes, but here we can see how each of the holes deviated, whether it was towards the face. Again, this isn't necessarily for this data set, so no need to worry about the relevance here. But what we're more interested in is the desired burden. So by going into this hole, we can see it is within its tolerance, and we're happy with it. But we can take that a step further under reporting. In addition to our burden or our driller's report, we also have our plan view and burden report. And our burden report would essentially break this down hole by hole, creating a different page, just showing the different burden measurements to the face for each of those holes. That are detailed here. If the hole goes beyond any measurement to the face, it'll just indicate it as infinity. We're able to see that in a table format, and then showing our weakest burdens along the middle there. And then that just breaks it down hole by hole. And then the top view report, I'm just gonna exit out and open that back up. Onto Blast Commander, and we'll go to sure, we'll go use this one. Already has all the information inputted, so I don't have to do too much or recreate anything. Essentially, the last thing I wanted to show you here was our plan view report. And so here, this is essentially what you're going to see. You'll see your crest line. The direction of your holes are in blue here. The weakest burden is indicated by your red or your green arrows. And then it also has the measurements hole to hole and to the row back. If we're working with a pattern that has hundreds of holes, maybe we can't fit this all onto one page, in which case we could add snapshots here, and we could add as many snapshots as we want, this will then be the title page showing this overview, and then each snapshot would have its own page following the title page there. And so we'll create this, and it will show this exact thing, but on paper instead of the screen. And I mean, I could probably talk about this stuff a little bit longer, but I'm not going to hold everyone up. That was in essence blast design as well as Boretrak importation. Next week we'll be getting into drill hole loading as well as timing and initiation.